All right, hello. Welcome everyone to our webinar on the QUBE Servo motor. My name is Tim Vrablik, and I'm a product marketing engineer here at Quanser, and I will be your host for today's presentation. I have with me my colleague Peter Martin, who is the engineering curriculum manager, and he'll be joining in through the presentation. What we're going to be going through today is we're just going to go through a quick introduction on the QUBE Servo. Then we will go through a demonstration of how to use the QUBE Servo, both for a USB and myRIO based panel. And that will be using QUARC and MATLAB Simulink and RCP Toolkit and LabVIEW. And then we'll wrap everything up with a couple of custom applications, just showing some advanced user capabilities with the Cube. So for those of you who aren't familiar with our QUBE Servo, this has basically been out for just about a year, but we're doing a bit of a relaunch with it because we have some new features and functionality. So the main uses for the QUBE Servo and the main benefits are that it has a fully integrated design. It is flexible with its digital courseware and textbook mapping applications, and it can scale from classroom to industry. So just giving a quick overview of the hardware itself, this is essentially what the QUBE Servo itself looks like. As you can see on the top there, we have a toolless magnetic quick connect interface. What this allows you to do is basically take any of the two default modules that we provide with the QUBE Servo, which are the inertia disk and the inverted pendulum, and it allows you to just quickly swap between one or the other using basically using magnets. The nice feature with this is that it doesn't require any types of tools in order to switch from one module to the other. You can also use this then to build your own custom modules that you can put on top of it, which we will get to some of these examples in the later part of the presentation. But just to give you an idea, you can put on a beam to do a ball balancing type experiment. The back panel, currently what you can see here is the USB version, and that's one of the ones that we'll be working with today. But we do have a direct I/O panel and an NI myRIO panel, and what that essentially means is that you can have these with the particular panels with the particular interface that you're looking for to allow the QUBE Servo to integrate seamlessly into your current lab. It also gives you the flexibility to then use software that you may already be using, whether it be MATLAB Simulink or NI LabVIEW. And again, the quality and precision machined aluminum housing for the full QUBE Servo just means that you're getting a high-end product without having to pay necessarily a high-end price for it. The price point for a QUBE Servo motor is ideal for any lab's budget. And in addition to this, it's a nice, small, compact, portable lab. So the footprint for it is really small, it's nice and slick, and it's really easy to use. So with our fully integrated design, the QUBE Servo can be used for multi-station, multi-course control labs for the cost of a single conventional workstation. So you can have multiple cubes within your lab for all of your students to be able to use with at the same price point as probably buying one higher end, more expensive, elaborate, custom type of lab. And again, the flexibility, it can be used with QUARC and RCP Toolkit. So for those of you who might not be familiar with Quanser and with our software solutions, QUARC is our software that we interface with MATLAB Simulink, and RCP Toolkit is our software that interfaces with LabVIEW. So, and we'll get a better glimpse of that later on through our presentations. You'll be able to see how the two pieces of software are compatible with them. Our flexible digital courseware, you can seamlessly integrate the hardware, software, and your courseware together, regardless of the type of class that you'd be using the QUBE Servo for. Now, ideally, it is designed for control theory type classes, but it can be used in pretty much any type of application that you would like. So with this, we provide you with a comprehensive and customizable digital media. What this essentially means is that you have the ability to take pieces of information that we've put together that can complement and really enhance the courseware that you might be using. Coupled with this, we have a textbook mapping that we provide so that you can see many of the textbooks that are used today in most common control theory classes for undergrad courses, and you could see what material maps to what textbook and how you can use that for labs and examples. Now, going from classroom to industry, the QUBE servo motor can scale readily. You can go from basic introductory concepts like modeling and PID control to something that's more advanced like state space representation, LQR, things like that. So you can really cover a full course in control theory for an undergrad level quite easily and readily with the QUBE servo. And again, it uses industry standard software. So the nice thing with this is, yes, we do have some custom software with QUARC and RCP, but they're being used inside of environments that your students will be using probably quite often once they enter the workforce. So it's a real benefit to be able to keep them within an environment that they'll be using in a professional setting once they graduate as engineers. So as I had said before, the QUBE servo comes standard with 2 modules. So these 2 toolless quick connect modules are the inertia disk module. So you can do things like step response modeling, measurement of noise, electromechanical modeling, PID control, stability analysis, just to name a few topics, as well as the inverted pendulum module for some more advanced types of control theory. So you can look at balance control, LQR optimization, swing up control. So again, just a quick sampling of some of the applications you can use with this, and Peter will actually show us some of these later on in the demonstration. Now, our online courseware, for those of you who are familiar with the QUBE, from about a year ago, we did provide all of this material on a DVD. We now have it all available for you online. So this right now, if you were to go to our website, quanser.com/courseware, you'll be able to access the courseware for the QUBE servo. And again, it is broken up depending on the software that you are wanting to use. So there's a LabVIEW section and a MATLAB Simulink section. So as you can see, we have sections that allow you to customize your courseware. So within that, you'll get our courseware index and guide and various types of documents that you can use. And you can essentially take it, and it's fully open and customizable, so it's not just a static document that's locked down. You can take any of the information that's in there, copy and paste it, modify it, and integrate it however you would need within your curriculum. With our QUBE servo setup, this is where you get the essential material for setting everything up. So a quick start manual as well as the user manual, so that's a really easy way to be able to get your servo up and running. Under lab experiments, there are various types of labs that are there, so fundamental labs and predefined sequences. So you can take things and run through from beginning to end directly the way that they're laid out within this section of the website. Or again, you have the ability to use that coupled with the textbook mapping to be able to create your own sequence. Within the systems models, we have all of the model documentation as well as worksheets for things like Maple, so that you can go through and you can actually see the mathematical modeling and calculation that's being done for the servo. Within our technical references, this is where the spec sheets are, so this gives you the full information on the servo itself. And then the ancillary material right now has things like our experts corner, basically impact of control, technology, lecture slides. This is actually probably out of the 6 areas, the part that will be updated relatively frequently, because as we get more material and more relevant information for the QUBE servo, we can just simply add it to the section of our website. So you'll find things there like videos or possibly white papers and articles and things like that that are directly related to the QUBE servo and applications that the QUBE servo could be used in. So looking at the lab experiment and the things that you would be teaching there, and then extrapolating it to the bigger picture idea. So again, this is what our textbook mapping guide looks like. So this is hopefully it's coming up clear enough on your screen. And here you can see along the top we have various control theory textbooks. So we've spoken to numerous professors both in North America and internationally to get a good understanding of some of the most common control theory textbooks. So with this textbook mapping guide, you can simply find the book that you're looking for along the top. And along the left-hand side, again, I don't have the full list displayed here on the screen, but you would find the lab example that you're looking for, and then you can then map the offerings with the QUBE servo directly to the particular section within the textbook that you're using, so that you can really get the examples from the textbook and the hands-on experience linked together. All right, so that wraps up this quick introduction to the QUBE Servo, and now we'll get to the more interesting part, which is the actual demonstration of the hardware. So I'm going to hand things over to Pete right now, and just bear with me as we swap our presentation responsibilities here.
All right, hello everybody. So basically what I'm going to do this morning is to just quickly run through some of the ways that you can easily and quickly interface with both the USB QUBE Servo that we have here and the myRIO QUBE Servo in both MATLAB and LabVIEW. So getting started, I'll just pull up my MATLAB session here, and I'll open up a new Simulink window. I apologize if I go a little bit quickly, but I'll be happy to answer any questions towards the end of the presentation. So the first thing I need to do is, if I go to my QUARC target section here, these are all of the different QUARC modules that we have built into MATLAB Simulink, and I'm just going to go to data acquisition, generic, and then the first thing I'm going to need to do is configure our data acquisition so that we know what we're talking to. So here I've got my hill initialize. I'll just double click on that. And I'm going to go down the list here and pick QUBE Servo USB, which is what I have plugged in over on the right here. And that should take care of all the configuration that we need for talking to our QUBE Servo. So the first thing let's do is send a signal out through the analog channel to the motor to get it running. So if I go to immediate I/O, I'm going to grab a hill write analog. So that's going to write any analog signals that we like to channel 0 right here. I'll just grab a constant here that I can just use to send out a signal. Just set that to 0. And then what I'm going to do is build our QUARC model here so that we have our real-time code that we can run in soft real-time on my laptop here. So that looks like it's ready to go. If I connect to the real-time code and give it a run, and I'll just update this value, you can see that now our motor is turning, and I can send it a few different values. And as you can see, if I bring up the webcam here, over here, we can see that the motor is turning over on the cube. All right, so I'll give that a stop. And what I'll do next is, let's say we want to read now the position from the QUBE Servo. I'll go back to my immediate I/O panel here, and I'll grab a hill read encoder. So that's just going to give me my encoder value off of the encoder channel 0, which in this case is for the motor. We do have a second encoder channel for the pendulum, which we could also read in much the same way. I'll grab a gain, just so that I can convert my encoder counts, which are going to be coming out of this block, to something more interesting like degrees. And then I'll connect that up to a scope. So this particular QUBE Servo has a 512 count encoder, so I'll just do 1 over 512. Oops, 1 over 512 times 4, because it's in quadrature, times 360, and that should give us the encoder counts that we need to get a value in degrees. Now that I've changed my block diagram, I'm going to build it again, just so it knows that we have updated code. And once that's done, if I connect and run this, then you should be able to see our encoder counts coming out here. You can see they wrap a little bit. We have blocks built in that'll compensate for that. And if I give this a 0 value and reconnect and run it, then you should be able to see that we are getting our values in degrees. So, as you can see, it's pretty easy, pretty straightforward. The QUBE Servo, in terms of interfacing, is very nice. This USB version here, all it has is just a USB connection and your power. So there's not a lot of cables. It's very simple to set up and to get running very quickly, both in software and in the hardware. So what I'd like to do now is I'll go to the website on the Courseware page that Tim mentioned earlier. Under MATLAB Simulink, I'll go to Lab Experiments, and let's just do a fundamental control lab. How about PD control? In this case, it's going to be position control. If I go to controllers here, then I have my download for my student version of the model. I'll just open that up and drag it to my desktop and open this up. And then basically this is just A little bit more complex controller than the one I just made, obviously, but you can see the structure is very intuitive. We have our signal generator coming through our control loop, writing values out to the motor, reading the encoders in. We have that modulus block that I mentioned would take care of that wrapping, converting it to radian, and we have our output position that comes out here. So I'm just going to make sure this is configured for my laptop, and then I'll give it a build. And this will take a little bit longer than the other one because it's a bit more complex, but it shouldn't be too long. Then if I connect and run this guy, then you should be able to see the position control response here on my plot, and you should be able to see it following the set point as much as I'm playing around with it over on the QUBE Servo. So as you can see, just right out of the box, doing simple controls with this setup is very intuitive, very straightforward. In MATLAB Simulink using QUARC. And then what I'll do now is I'll switch over to LabVIEW using our equivalent software, RCP, for rapid control prototyping. And I'll go just really quickly through a very similar process. In LabVIEW, if I go to New, then in this Quanser section here, we actually have a template that you can use for a basic hardware loop. So it saves a little bit of the configuration, makes things a little bit quicker. So I'll open up one of these. You can see we have an equivalent hill initialize block here where we can set up the interfacing with our hardware. So in this case, I'll just open up the hill initialize, and I'm going to choose again QUBE Servo USB down here. You can see there's a little photo of it. And then again, as we did with QUARC and MATLAB Simulink, I'm going to go to our RCP palette here, immediate I/O, and let's write a value out. I just need to wire up the board information here so it knows what it's talking to, and I'll just create a little control so that we can set the value. And now on our front panel, we should just be able to run this, and very equivalently to what you saw before, I should be able to send signals out to the QUBE Servo. You can see now it's spinning in much the same way it was earlier. And then again, let's just really quickly grab our encoder, and I'll show you that equivalency as well. We have our hill read. Just drop that in there. Again, I need to wire up the board information. And then if we want to put this in degrees, then I'll just drop in a gain block. So we can convert that over. If I remember my math correctly, I believe this should be somewhere around 0.175. And then let's just drop in a scope so that we can see exactly what we're looking at here. So I'll just grab a waveform graph, drop that in, go back to my front panel, and we should be able to see the value in degrees in much the same way as we did earlier. Just take a second here to run, and then you can see here we've got our value in, oops, what did I do? Oh, I know what I did. I have to change this to encoder. It'll default to an analog channel, which in this case there is none. So if I switch that over to actually reading the encoder values, then it should be ready to go. You can see we have some nice intuitive error messages here that'll tell you exactly what you're doing wrong and help you out if you make mistakes like I do. So you can see here, now we've got our degrees coming out. So again, it's very simple, very intuitive. You can see the block diagram can end up being pretty simple to put together and have students build themselves, or you can give them the models and have them walk through them. What I'd like to do now is I'll save this on my desktop, and I'm going to deploy it onto the other QUBE Servo we have here connected to the myRIO. So I'm just going to go again, File, New, and this time I'm going to create just an empty project, because in order to deploy onto the myRIO, you have to have it in a project. I'll close this VI for now. And then what I'm going to do is, now that I have this project, I'll just save it on the desktop as well, I'm going to want to add the myRIO to it. So I'll go New, Targets and Devices, and under myRIO, it should detect the myRIO that I have in the room here over our little Wi-Fi network. There it is. I hit OK, and it'll take care of all the configuration, add it into our project. So now you can see it's down here, and all I have to do is just basically take that VI I had earlier and drag it down to the myRIO. And then when I reopen this, when I run this in a couple minutes, basically this will just now run on the myRIO exactly the same way it was running on my laptop with the USB version of the QUBE Servo. So when I open this back up, the first thing I'm going to want to do is go back to my hill initialize, and now that it's running on myRIO, it's not going to be the USB servo, but it's going to be the myRIO servo. So I'm going to have to change the hardware that I want it to talk to. In this case, I'm talking to the myRIO on the A connector. You can see there's two connectors on the back of the myRIO here. You can plug it into either one. In this case, I'm just using the A connector. And then if I run this, it'll deploy onto the myRIO, and it should run again in very much the same way, but as a nice sort of remote lab feature. So this is wireless. It's just got the two power connectors here. And so basically, you could have this running in a lab. You could deploy code to it. You could do all sorts of things like that, and it would all be very intuitive and simple to send the code out over Wi-Fi and have it run remotely. That also offers advantages to being able to deploy things in different ways, and you can also interface via USB cable also. I'll show you in a second the VIs that we use with myRIO. They come pre-configured with an address for a myRIO that's plugged in via USB. So just to highlight a little bit later, you have to make sure that you're actually finding it properly, but it should work in very much the same way. So now you can see I'm getting my encoder values on the QUBE Servo myRIO, and you can see I've got my motor running the same way. So there you have it, deployed onto the myRIO. One last thing I'll do, just to highlight again what you can do. I've downloaded earlier one of our curriculum VIs, the Swing Up controller, just from the website. So I'll open that up. It's going to open in a different project. But again, the project should be able to connect to the myRIO in a very intuitive way. Over here, I'll just quick connect my pendulum on here. Just move this out of the way. And plug in the encoder for the pendulum. And now this is ready to go. It's very quick and simple. And then here on my project, as I said earlier, what I'm going to want to do is make sure that this address matches the myRIO that I've got. So this is pre-set up earlier. Should be good to go. I'll just connect to it, make sure that it can find it properly. This may take a couple seconds, and it's going to complain because I already have code running on there, but it should be good to go in a second here. And then down here under the myRIO, I'll open up, again, my Swing Up VI. This VI is basically just running a controller that's going to, you can see it's a little bit more complicated, but basically what it's doing is just taking in our state of the pendulum system, running it through a state feedback gain that we derived in some other labs. And then in parallel to that, as a sort of a hybrid control scheme, we have our Swing Up controller, which is trying to bring the energy of the pendulum to the point where it inverts, just using a simple algorithm that's more or less like a proportional controller. So if I deploy this, it should start sending the code over to the myRIO here. This may take a second for it to dump everything over.
Okay, and while we're waiting for this to be deployed over, I just want to send a quick reminder out to everyone that if you do have any questions, feel free to enter them in at any point in time into the question window on the right-hand side, and we'll try to address as many of them as we can at the end of the presentation.
All right, looks like it's running. So if I just give it a little tap to give it a little bit of initial energy, it'll start trying to swing itself up. And then because this is a student model, I don't have the gains set up immediately that are the ones that it needs. So I'll just adjust my parameters a little bit here to give it a little bit more energy. And eventually, it should invert. There we are. So you can see now it's balancing nicely. I can give it a little bit of perturbation and I can compensate for that. And so you can see just getting from very simple VIs and very simple MATLAB Simulink models to more complicated systems like this. It's all very easy and intuitive and really ideally suited to an undergrad controls lab.
Okay, great. Thanks, Pete. I'm just going to switch things back over here and just have a couple of slides to go through, not too much more. So what I have here are just a couple of video examples of some additional applications that we've created or some users have created using the QUBE Servo. So for some of you who are familiar with Quanser, you might be familiar with our driving simulator that we use with our standard servo motor labs. So using two of them in that type of an application. Here we have two cubes that are being used for this driving simulator. So as you can see, with the disturbance on the left-hand side, oh, and it seems that the video is a little bit choppy here, so I apologize if there's a bit of a lag with the video on your screen, but essentially on the left-hand side, that would be controlling the speed, and on the right-hand side, controlling the direction of the car in the simulation. Now another example here, this has a custom interface on it, and this is balancing a ball on a beam. So this is using the magnet quick connect option there to build a simple beam that was used at a connection point using a 3D printer. So now you can do things like balance control with the ball on the beam, and here you'll be able to see in a second on the video. It's just a quick magnetic interface that you can pull off and on to create your own type of lab experiments. And last, a much more advanced example here is using the QUBE Servo with the myRIO along with a Kinect and a webcam. So the first part here is showing basically using a webcam to measure the position of the ball on the beam, and essentially just using that to be able to control and balance the way that the ball and beam are operating, so everything is stable. What we're showing here now is basically the fact that this is all connected to a myRIO. And then in the last part here, you can see basically now this is using a Kinect, and the positioning of the hands. Pete is one in the video here, and he's basically moving his hands back and forth, and that's giving you the position of the ball on the ball and beam.